Hi everyone, in this video we are going to be learning about dilations in the coordinate plane. So if we take a look at the picture here, a dilation is shown and it asks us, does the dilation represent a reduction or an enlargement? So if I zoom in on our picture, we want to take a look at where the prime symbols are. That indicates that that's the image after the dilation. So we can see that the triangle got bigger, so that tells me that this is going to be an enlargement. Okay, if we saw the triangle got smaller, we would call this a reduction. Then it asks us, what's the scale factor of dilation? And K is generally the variable used to represent the scale factor. So for this, when we're trying to find the scale factor, we're trying to figure out what were we multiplying by to get the actual image here. So we want to compare something from the pre-image to the image. So there's a couple options of what we could do. One thing I can do here is if I take a look at the length of RI, I can see that this is 8 units. If I take a look at the coordinating side in the image, R prime, I prime, I can see that's 16 units. So since we can tell that this has been doubled, I know that this is a dilation of scale factor 2. It's whatever you are multiplying by. So dilations are always multiplied or indicate multiplication. So in this case, K, the scale factor is 2. Now this dilation is centered at the origin, which we're going to talk about in a second. So here's some key facts about dilations. For every dilation, there's a fixed point, and that's called the center of dilation. Since the point is fixed, that means it doesn't move, it doesn't change, regardless of what the scale factor is. When a dilation occurs, the distance from the pre-image to the center of dilation is altered by multiplying the original distance by the scale factor. For our second bullet point, a dilation is not a rigid motion because while it preserves angle measure, the angles do stay the same under a dilation. It does not preserve length. We can see that in the diagram we looked at above, that the length of the side was doubled, therefore length was not preserved. Therefore, dilations create similar figures, not congruent figures. Okay, we've talked about other transformations such as reflections, rotations, and translations. Those are rigid motions. Those create congruent figures. Dilations do not. All right, so let's look at some sample questions. We're going to start off with just dilating an actual point, and then we'll move on to segments and shapes. All right, it says A is 5, 4. Find A prime after a dilation of 2 about the origin. So here's what I'm going to do, and here's how I'm going to show you to do a dilation, just to make it easier for when we look at problems that are not centered at the origin. So what we're doing is we are multiplying the distance from the origin by 2. So here's the origin, and let's see how far A is from it. It's 5 boxes this way, 5 units, and it's 4 units up. Okay, so it was 5 this way, 4 this way. I'm going to just switch colors here for a second. Now I want to double that since my scale factor is 2, so I want to go 10 units to the right. And let me fix that and put that back in here. So I'm going to go 10 units to the right, and instead of going 4 up, I'm going to go 8 up. Remember, I'm doubling because in this case, we have a scale factor of 2. And there's my coordinate of A prime. So it looks like A prime in this case is going to be 10, 8. And you might notice that basically the original coordinate was just doubled. We multiplied by 2. That will happen anytime you are dilating a point or figure and it's centered at the origin. You can just multiply the coordinates. It does not work on question 2 though. So if A is 5, 4 again, we're also doing a dilation of 2, but now we are centering it about 1, 1. So in this case, we cannot just multiply the scale factor by the original coordinate. The answer to this problem is not 10, 8. So we have to do it the way I showed you in the previous question. So I'm going to plot 1, 1, the center, and I'm going to count boxes. So 1, 2, 3, 4. To the right, and 1, 2, 3 going up. So we are going to double each of those values since the scale factor is 2. So 1, 2, 3, 4, 5, 6, 7, 8. And we're going to double the change in y values to 6. So 1, 2, 3, 4, 5, 6. And here's our coordinate of A prime. So it looks like our coordinate of A prime in this case is going to be 9, 7. Okay, so again, just to recap those two questions, if it's centered at the origin, you can take a shortcut and just multiply. If it's not centered at the origin, we're going to have to count boxes. All right, let's look at some more sample questions. Now we're going to look at some line segments. AB, segment AB with A negative 6, 8 and B 4, 4 is shown. Plot the image after a dilation of 1/4 centered at the origin. So since it is centered at the origin, I can multiply K, the scale factor, by the points. So if I did that pretty quickly here, if I take negative 6, 8, and I multiply that by 1/4, I would get negative 6 over 4 or negative 3 over 2, comma 2. And B prime would become 1, 1. So I have my answer without actually referring to the graph at all. If I did want to look at the graph, I would plot the origin. And I'm going to count the boxes. And I notice that I'm going 6 this way and 8 that way, and I would have to divide those values by 4. So I would go negative 1.5, right? The negative 3 over 2 is negative 1.5, comma 2, should be here. And B would end up being 1, 1. And there's my segment after it's dilated by 1/4. One thing to note is that slope is preserved under dilations, so our preimage and our image should look parallel to one another then. All right, let's try one where it's not centered at the origin. So we're given segment AB, 2 new coordinates, negative 8, 5, and 0, 7. We want to dilate it by a scale factor of 0.5 or 1/2, centered at the point negative 4, 3. So I'm going to plot the center here. And I'm going to count my boxes. So I see it's 1, 2, 3, 4 this way, and 2 going up. And I want to have those values. So I want to go 2 to the left and 1 up, which will make A prime here. And now let's do the same process with B. Start at the center. Okay, so your center basically is your start when you are counting your boxes. So from the center to B, I am going 1, 2, 3, 4 over. And I'm going 1, 2, 3, 4 up. So now I'm going to go 2 over and 2 up. I'm having that. So here's B prime. And we have our segment. It doesn't ask us to write the coordinates, but I'm going to write them anyway here. So A ended up being negative 6, 4. Or A prime, excuse me, and B prime ended up being negative 2, 5. Number 5, triangle A prime, B prime, C prime is the image of triangle ABC after dilation with a scale factor of 3. Are the triangles congruent? Explain. So they are definitely not congruent, so I'm going to start off by saying no, because the side lengths were multiplied by 3. And I'm going to add to that if the length or the side lengths are not preserved, the triangles cannot be congruent. Okay, so even though angle measure is preserved, in order for congruency to be preserved, both angle measures and lengths need to be preserved, both of them. Number 6, triangle JKL undergoes a dilation of 2 centered at the origin. Which statement is true about triangle J prime, K prime, L prime? All right, well, remember we were just talking about that the side lengths are multiplied by the scale factor. So if I take a look at choices A and B, they look very similar to one another except the 2 has been moved. So choice A is saying multiply the image, the after, by 2 to get the pre-image. That would be incorrect. Choice B is saying multiply the pre-image by 2. That is going to be our correct answer here. But let's also talk about why C and D are automatically incorrect. Angle measure is always preserved, so angle measure never gets multiplied by anything, so C and D cannot possibly be correct answers. All right, let's look at a couple more. Number 7, triangle ABC undergoes a dilation of 2 centered at point B. Plot triangle A prime, B prime, C prime. All right, so from B to C, I have 7 units, so I need to go 14 units away, and that's going to land C prime over here. From B to A, it's left 7 and then up 2, so I'm going to go left 14, up 4. Here's A prime, and then I'm just going to make nice straight lines connecting them. B is not going to change. Since B is the center of dilation, think about our notes on the first page. The center of dilation is a fixed point, so it does not change after the dilation. All right, last question here. Rectangle MATH was dilated. Describe the dilation that occurred. Okay, so the first thing I notice is that the shape was reduced. So I know my scale factor should be something less than 1. It has to be a fraction less than 1 because the size decreased. I also noticed that MA was 3 and now it became 1. I noticed that MH was 6 and then it became 2. So I can see that everything was multiplied basically by 1/3. If you were thinking divided by 3, that's the same thing as multiply by 1/3. We just use scale factors as multiplication. So I'm going to say that this was a dilation of 1/3. And anytime we're going to describe a dilation, we are going to talk about what the center was. So a dilation of 1/3 centered at. Now, most often it's going to be the origin, and here's how I can check that. Let's pick a point. So let's say I pick, I don't know, A. A is the point -3, 6. Its coordinating point, A prime, is -1, 2. Does this represent that shortcut method where you can just multiply? And it does. So that tells me that this is, in fact, centered at the origin. Okay. If you think about the origin, multiply the coordinates by 1/3, they won't change. Okay, hopefully this video helps you understand a little bit more about dilations. In the next video in this playlist, you are going to learn about dilating linear equations. Thanks for watching.